Welcome to episode 12 of the AI Infrastructure Podcast with me, Kai Hendry, in the UK, and Vincent Smith over in Vietnam. In this episode, we talk about CDK-TF. And long story short, we try to rationalize where CDK-TF fits in light of the recent deprecation by HashiCorp/IBM. And we do justify CDK. Well, let me give you a summary why we think CDK is important. It's a high-level abstraction, and it allows complicated cloud infrastructure to be reasoned about. It allows you to get the most out of the cloud, to differentiate. And if you just think conversely, perhaps, if you vibe coded your infrastructure using, I don't know, AWS CLI or something, you just couldn't get a solid, reproducible, deterministic infrastructure that way. You need high-level constructs that the AWS CDK sort of provide you. So you ideally need to work with it. So in light of the deprecation of IBM, we need to find a place for CDK, a programming language, in order to do the next level stuff with the cloud and infrastructure. So enjoy the episode. Please, if CDK-TF doesn't tickle your fancy, check out the other stuff in the playlist. And have a Merry Christmas. See ya. Goodbye. Yeah, this guy. Which guy?
So since CDK-TF was sunset by IBM, and I created a fork under a project that I built a bunch of CDK-TF L2 constructs, there's one guy who's been contributing 3 PRs over... Well, so far he's contributing, I think, 7 PRs already, and I've merged 6. And he keeps adding cool stuff. It's amazing.
What?
Yeah.
So you just forked it and
No. He contributes. So the one that I forked, I put it on pause, right? We're waiting for a go-ahead. We're collaborating with the Open Constructs Foundation, which hosts several of the CDK-related projects. And we're trying to find a final and good name. Hopefully we don't have to rename, but I seriously doubt that HashiCorp is going to allow us to use the original CDK-TF package names. So we'll probably have to rename it. And I renamed it TCons, which is Terra Constructs. It's a 4-letter acronym, and people obviously don't like that name.
TCons sounds familiar now.
Yeah, Terra Constructs is the library that I built.
Oh, okay.
Yeah, so TCons is what it's a scope that I have on npm.js, so I use it for a lot of stuff. So I was like, yeah, I'm just going to reuse. I just took immediate action, right? Fork it and rename it to my stuff. And then... So it pushed my project in the foreground, and we're holding on the fork because we don't have the final name. And I agree, maybe we don't call it TCons. But at the same time, somebody else took notice of my other project and has contributed about 8 PRs to it. And they are all high quality.
Can you show
PRs.
me? Can you give me a link? I'm just curious to see what this contribution is.
Yeah. It's on my... Here. I have to get used to this thing jumping around. Hold on.
But you mean your Arch Linux?
Oh, yeah, I use Arch, by the way. It's never gonna get old. I'm gonna keep saying it. Okay, I send it on Zoom.
Yeah, like Primogen says it a lot, doesn't he?
Does he use Arch?
We're just following other YouTubers. It's so sad.
No, but then I have to start whining like Theo. Shots fired. I'm already doing the job whining, right?
One complaint that I get from my YouTube channel is that, like, Kai, yeah, I like your content, but you complain too much, so I can't watch you. It's like, what? Do I? Am I that guy? Okay. Refactor. Use AWS CDK. Oh, hold on. Let me see if I can share my screen.
I've been digging into that PR because it actually enables really cool stuff. So basically, a little bit of background. AWS CDK has this regional information library that keeps track of like which capabilities are available across the regions. They download a fact table like Lambda runtime support for Node.js. Latest is version 22 in China or government region, for example, but it's version 24 for other regions where Node.js version 24 has already been deployed, right? It takes time for this stuff to deploy. So other stuff is like S3 bucket endpoints or like the domain suffix of an S3 or regional endpoint, right? The URL suffix that they changed the way that S3 works over the years. So new regions, they use a different suffix. So the
Yeah,
AWS
yeah. You know, I
CDK,
think I noticed that.
yeah. So the AWS CDK has logic in it that uses a fact table about the regions to figure out how to build a bucket, or like if you give it a bucket URL or just a bucket name, and it has a regional, like your AWS CDK stack has a region, so then
Yep.
it uses that information to find out what's going to be the domain URL for that bucket depending on the region. So I had copied that over. I had copied over the fact table into my code because I didn't know it was a separate package. And he says, well, we don't have to copy over the details. We can just reuse the AWS CDK package on top of CDKTF.
Cool. This
So,
actually looks like a pretty good contribution. Holy moly, I'm
oh yeah, dude,
impressed.
all of his contributions have been absolute fire. The only thing is he doesn't write integration tests. So every single one of them I check out and I build an integration test and I validate that you can actually Terraform deploy it into AWS and doesn't get any errors. Yeah. But he's been aligning Terra constructs closely to AWS CDK.
Cool. So I got a couple of maybe noob questions for you, but like, I guess this might serve the audience. So CDK for Terraform basically allow people to write in that familiar CDK style, which came out of
AWS.
AWS. What's his name? Ben Israel, right? That
Yeah,
guy.
Elad Ben Israel.
Who was it again? Is it worth mentioning a name?
Who? What? Sorry.
Who was the guy that was in the original team that he left and he did Winglang or
Yeah,
something?
Elad Ben Israel. Elad Ben Israel. I
Oh,
forgot the
I
name.
wasn't wrong with the name. Okay, sorry.
Yeah, yeah.
I thought I was making up his name or something. So CDK, cool beans. I think we went through yesterday that it was like the the thing that really makes it different is that it's operationally friendly. You can refactor this stuff, and it's a programming language, unlike maybe Terraform and things like that. Now, the thing that I don't understand is how it links up with Terraform, A, and
Mhm.
B, what did actually CDK for Terraform actually provide? Did they provide everything that Terraform providers did, or was it a subset?
Okay. So the Cloud Development Toolkit (CDK) from AWS is built upon, and they've split this out like some composable ideas. So one of them is the concept of constructs. Constructs are basically objects that know how to synthesize or write themselves out into like a small little snippet of configuration, right? If you use a construct, and they are able to be composed into trees of constructs, so you can nest constructs into other constructs, and so
Yeah,
with
don't
CDK,
people sometimes call them? Oh, is my webcam just stopped? Don't some people call them like stages or something like that?
no, stages is something else. I think it's if you are doing like CloudFormation deployment across different environments, I think you can define stages
Okay,
to
fine.
like duplicate stacks. I mean, I know that CDK pipelines uses stages. I know that there's a concept of stages within AWS CDK, but the thing is, first AWS CDK was built within AWS, right?
Right.
They had a couple of crucial innovations in terms of infrastructure as code. The first one is a tree, a composition of configuration that starts at the root node, which is usually your app, your entry point. And from there on, you tie like a tree of constructs. And each one of them have a little bit of configuration like information. So they know how to synthesize out into a configuration target language. So if you use AWS CDK, the constructs that you need are the app, the AWS CDK app, that synthesizes itself down to a CloudFormation stack.
Right.
And then each construct that you put inside those apps will be a CloudFormation resource, right? Because within a stack, you use CloudFormation resources, right?
Right.
And now if you apply those ideas on top of Terraform,
Right.
so when they port over the app, it's basically something that represents a single Terraform root module, right? If you talk about Terraform nomenclature or concepts,
Terminology.
yeah. If you basically have a directory and you drop in a config file and then you run Terraform init, it will consider that directory as the root module, right? And then if you create another directory and you put in some config there, and then you include that directory as a module, that will be like a sub module, right? So in Terraform, constructs are kind of like directories of configuration files, and you source them into like module source, and then you can nest those modules as well. But the one that is the actual app entry point is the root module of your directory, right? When Terraform runs, it will find the Terraform configurations in your directly sibling files and aggregate everything into a single config in memory, right? Both HCL, which is a superset of JSON, and some JSON if you want. And then it will create in memory your Terraform configuration. And then within that root module, you may refer to other modules that are coming from either
So does it write it
subdirectory.
out as normal Terraform so you can inspect the Terraform?
Yeah, so the whole greatness of CDK for Terraform is that ultimately what you get once you synthesize or serialize that construct tree down to the target language, you get pure and raw Terraform.
And is it readable, or is it like
It is
nonsense?
so it's very readable. There's a couple of things that may make people upset, because in the construct tree, the identity of a resource, like if you write Terraform, you're going to say AWS underscore instance, and then you give it a name like web, and then you put in the config attributes such as VPC ID, instance type, EMI, like what's the image that needs to be provided, right? So the name, right? So you have AWS underscore instance, and then you have the name web. When you serialize from TypeScript down into that config,
Yeah.
kind of flattens everything. So it does some type of unique ID
Oh,
generation.
that's a good thing though. I thought we discussed that.
No,
Like
no, no.
having,
It creates a unique logical ID. So that resource, it's not your physical ID, because in any case, when you create an instance in AWS, your physical ID is, you cannot determine it either, right? Not all AWS resources allow you to determine your physical ID. The instance ID is I dash blah 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 blah. Your load balancer ID is is LB dash something. But if you do a bucket and you say I want the bucket name to be foo, it will be exactly foo and globally unique. You will not get it even if somebody else created a bucket foo, right?
okay.
So some resources, they allow you to determine or to define your physical ID, and some resources, they don't allow you and they automatically get an ID. But here I'm talking about the logical ID, right? Even though the logical ID will be something that you write in your configuration file. So if you ask me, like, does it serialize to readable Terraform? It is. Just the logic IDs have these weird suffixes that you can actually disable if you want. You can actually go and say, don't give me these hash suffixes, but they're used to make things unique. They used to make sure that the logic IDs don't have any conflicts. So that's the only thing that I think people, when they first look at it, kind of get annoyed by, is like, why these names so like have this weird checksum this hash at the end of the name. And that's purely because they don't want to have a conflict or an error when you have like nested paths that all get serialized down into the root module. So CDKTF also supports modules, Terraform modules. By the way, you can refer to an existing Terraform module. So it's very good for an existing team that is already using Terraform modules extensively. With CDKTF, you can take that Terraform module and convert it into a TypeScript interface. So it reads the full module definition, looks at all of the variables and their types, and then creates an equivalent type.
In my current client, we switched to Terraform. They're a CDK shop, but when I joined, we basically set up a new workflow with Terraform because of Snowflake. But it sounds like I could have used CDKTF to bring in the Snowflake Terraform provider into CDK world, right? Or am I misunderstanding?
The CDKTF provider would allow you to, so that's one thing, right? You can create bindings for modules, and it will look at the variables that the module take and then generate a TypeScript interface. Or you can create bindings to Terraform providers like the Snowflake provider. And yes, you will get a TypeScript interface, but no, it will not allow you to use it with AWS CDK, right? Because AWS CDK only works with CloudFormation, and the CDKTF generated one will generate Terraform.
Yes. So, but I mean, to be honest, I'm not a huge fan of all the. I mean, this magic converting different bindings of different languages into CDK kind of makes me nervous.
No. I want to clarify one thing, right? In itself, creating a Terraform provider, reading in the Terraform provider resources and generating TypeScript bindings or Python or .NET or whatever on its own has very little value, honestly. You just get these like L1 constructs, and you now can call that constructor. And maybe the one thing that you get is you're able to use like lazy evaluations. Basically, you can, for some attributes, you can provide a function instead of an actual value. And so when it synthesizes, it's going to execute the function to basically decide what the value for that property needs to be. And that is very powerful already, right? Because it means that depending on how you call it, a function can execute and then determine what the value for this particular attribute could be. For example, if you are, where is this like really useful? Yeah, maybe in IAM policies, right? Let's say that you are building some type of infrastructure and you're using an IAM policy and you're using a bunch of other resources, and you want the policy to be generated at the very end after the user has already defined the full program and all of the configuration that he wants to be generated.
Yeah, there is a least privileges type thing.
Yes, the functions can be very smart and identify exactly what are the actions that need to be added into the policy, depending on what the user, connected. So it's kind of a mixture of like an imperative language to create a declarative definition of infrastructure as code. And like people are like, oh, why would you do that? IAC is all about declarative. You cannot mix it with imperative. You start doing that, people will no longer like know exactly what's going on. But if you look at the language itself, since Terraform 0.12, before it became stable, they added list comprehensions, they added dynamic values, dynamic, for each. Yeah. And there's a very clear reason why they did that. Because you can't manage AWS resources with pure static definitions. Before that, you have preprocessors. People wrote template languages to generate Terraform configuration.
I feel this is a trend in infrastructure's in infrastructure game. Is like the days have gone where you can just declaratively put things in YAML, right? You need a programming language in the mix.
You're going to keep adding layers and layers of abstraction to work around this this core missing feature that you are not working with a proper programming language, and then you start adding config language generators.
I guess in a very succinct way, CDK gives you the binds to a proper programming language, and that's really what it does, right?
Yeah. But still, I mean, and then it gives you the ability to do lazy evaluation, so late binding, so that you can evaluate the full program, and the user can imperatively build up the configuration. So he can take some object that somebody else wrote and then invoke some methods on it to mutate this, the object to their liking. Like, for example, in CDK for Kubernetes, when you create a deployment, it's going to define a pod template and then a replica count, that how many times you want that template to be created to create the pods, right? And then you want maybe to set some type of anti-affinity. So you can do all of that declaratively in Kubernetes, and it's not a simple configuration system, because to define a pod template with anti-affinity rules, to be fully flexible. And this is also why people like Compose, right? Compose is super simple, but like Kubernetes has all the little dials and knobs.
Sorry, what's Compose? Oh, with a K, you mean?
Docker Compose, before that, or ECS. People like
ECS.
Docker
Compose. Oh, okay. Yeah. I love Docker Compose.
To
I love it.
Because it gives you like this very simple thing. But if you want to do something, earlier you were complaining, yesterday you were saying Vercel is great, but if you want to do like a custom type of database, I can't do it. I need the dials and knobs. Well, that's where it breaks, right? These abstractions. So the same way with Compose, and that's why Kubernetes has like everything under the sun, right? You can define exactly what resources on the node need to be available.
YAML for days and cross-plane.
Yes, and so the actual configuration you have to write becomes super complicated. Kubernetes is the same thing. You end up with like hundreds of lines of YAML.
What is the so I got CDK is the programming language answer to maybe Terraform, but what is the programming language answer to
Kubernetes?
Kubernetes?
So AWS built CDK for Kubernetes. There's one guy, Ilya, he did a lot of he's one of the main contributors. Yeah, I loved it. Like initially it was a bit frustrating because one of the things you learn as a Kubernetes administrator, and if you go for certificates, which I never do because I don't think they're worth it.
Oh dear God, don't go there. That's a rabbit hole.
Yeah.
Was this another Ben Israel thing?
No, but it comes from within AWS. But it applies the same idea of creating a tree of constructs, and the same idea of building like the core Kubernetes API objects, which are pod, deployment, replica set, service, and all of these, right? And now he's doing robotics lab. Anyway, so Ilya is one of the guys that like I see contribute and react and still maintain this project mostly. I'm sure there's other people working on it. But the greatest thing here is the moment you have built those core API objects, you can still write this, create your Kubernetes configuration, but it's honestly worse than YAML, because you have all of these additional curly braces and very nested, like complicated configuration. So pure L1 constructs, this pure language binding, are not very useful. But what's immensely useful when you work with CDK for Kubernetes is that they build these higher level ideas of like, we're going to wrap this low level API object that's called a deployment, and we're going to add a scheduling namespace. And we're going to add the idea of spreading pods on the scheduling namespace. And suddenly you are defining like, I want to spread this across nodes. And there's you go like my deployment.scheduling.spread as a method. Your intention is to spread these pods. That's your intention, right? And that gets translated into a declaration, an actual rule on the pod.
So
anti-affinity.
These that sounds like a good, useful abstraction. But so what abstractions? Oh, plus. Sorry.
Yeah, plus is the real power, because that's where they create these high level like deployment and cron job, and then they make service, and then they have like reasonable defaults. So with very few lines of code, it's kind of like Helm, right? But Helm is declarative, like YAML config files with no schema. So you don't get IntelliSense. You don't know exactly like where do I need to put this configuration for it to end up where it needs to be, because YAML Helm doesn't have any schemas.
That's
And even in
interesting.
later versions, they try to add schemas, but it doesn't really
So
work.
have you used this in production? You just checked it out.
No, I was at an organization that had everything under the sun. They had Helm, they had JSONet, they had Customized, they had,
Oh my God.
yeah, they had everything.
And did you
So
introduce something new while you're there?
of course, I built a new standard, but I did more than that. I did not just add a new standard. I actually built a bunch of migration tools for everything else. So I had like a very clear path. Like if this is a service that you're working on, and we were adopting Argo CD, and the only way to adopt Argo CD was to adopt CDK for Kubernetes. So I made it so that you can't go and manage your service with Argo
Oh
CD
yeah.
without
Actually, I don't
adopting
think
this.
we've ever really talked about GitOps. Are you a GitOps? I mean, do you have any opinions there quickly?
Yes, I
Oh
I
my God, maybe
run
we say
Argo
that for another
CD.
video.
I ran Argo CD since 2019 and very quickly realized that a lot of people like to do magic on the server side, and they like to minimize the configuration that goes in. And then they like to Argo CD to like expand everything using Helm rendering like last
Oh,
minute,
oh
right?
no, 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 no. You want
And
Argo CD just to be UI is or
yeah, yeah, exactly. You want Argo CD to take whatever is in Git and fire it straight at Kubernetes,
exactly.
and then get back
Yeah,
the error message.
that's one thing I used Argo CD in Anger, and that's one thing that was really
Yeah.
crazy. Like, why mix it up?
Yeah, so they build all these amazing customized plugins and Helm plugins to run on the Argo CD server, and that's the first thing I throw out
Yeah,
because you
geez,
want,
you and
and
I
they call
are
this
brothers
the
from
rendered
another mother.
manifest pattern. Sorry,
You and I are a little bit too similar.
but you know why this is relevant? Because this is called the rendered manifest pattern, and the core creator of Kubernetes, like one of the co-founders, Brian Grant, and one of the co-founders of the idea of GitOps for Flux with Weave, and you know there's Flux CD and there's Argo CD, and
Yeah, I
Argo
don't.
CD
Yeah,
won on the
Flux used to be a
UI.
contender, right?
I think Flux is still a contender. They broke it down into microservices. They make it, it's way more performant, but it doesn't have a fancy UI. So everyone loves Argo CD, but nobody like Flux is still evolving. But again, like I haven't run Kubernetes for 2 years. But what I wanted to say is that the guys that are very, you know, smart people, Brian Grant and Richardson from Weave, they created the logical extension of this rendered manifest pattern. So basically, the idea of like you make sure that everything gets rendered down into manifests into Git, so Argo CD can purely track a raw manifest and just fire it off after Kubernetes, and then you are able to validate immediately what is the error message that Kubernetes sends back, because it just relates directly to whatever you have in Git. So you can see very clearly. So they evolved that pattern and they call it config hub. So instead of just like having a very dumb Git database, they built a specialized database for storing these configurations. And then the idea of like making a change, you can go straight into config hub and make a change where it needs to be, so you don't need to go through the Git pipeline. And then you can also call functions if you need to make a change across
Wait,
5
wait a minute.
different environments.
I thought we established that changing things outside the pipeline is a bad idea.
So they turned it upside down, and then they provided a config hub that helps you make changes in a controlled way and in a repeatable way, because it's kind of like functional programming. You can register endpoints on top of your config data, and then you can apply functions. So mutate your config data across your whole environment, and then you can do it with an approval step workflow. So you just select what you want to affect, you apply the function, you can see a preview, and then you can approve, and then boom, it's GitOps. It GitOps in a like reasonable way
So
without having
have
to
you used
grow.
this product? Have you used this yourself?
No, but I understand the idea, because a lot of what he built originally with Customize, you know, the idea of applying JSON patches, they kind of like extended it as those JSON patches now run as part of like end hooks. I haven't used it. They just made it like
Oh yeah, we were
publicly
talking about
available.
hooks yesterday. What was using hooks again? Oh my God. We talked about
Pulumi can do
hooks.
hooks
Yeah.
while
This
you're
hooks thing is
synthesizing,
a
and in the AWS
yeah.
CDK as well. This kind of a
So
little bit different hooks. Yeah,
yeah, but
but this
I
one is
think I'm joining
purely
it in my
for
mind.
I don't know if Config Hub can manage any other configuration except for Kubernetes. This is like firmly settled in the idea of like a reconciliation loop and having a control plane that constantly runs these reconciliation loops and automatically adjusts your, like with eventual consistency, adjust
Right,
your cloud towards it, right?
right. So
Which is one thing that Terraform does not have, right? Terraform, you run an apply and it doesn't touch it until the next time you run an apply. Where Kubernetes is constantly re-evaluating your infrastructure and making sure that it is aligned. Yeah.
yeah, the one thing was so like let me start with the problem. What we're using Terraform. Uh, Actually, this is a problem with CDK too. The whole CDK deploy thing is a bit slow, but okay, never mind
But
that.
that's CloudFormation issues.
That's infrastructures. Yeah, that's cloud formation issues. But stop me if I talked about this before. But one issue that we have right now is that we're using a database. We're using Terraform to manage Snowflake, and we don't want to delete the resources because that could lead to data loss. In all honesty,
Yeah. So that's
and we
where a
don't
lot
want to
of people,
recreate resources. So
yeah,
I have like some
worried
crappy,
about constantly like
yeah,
if you
I
have a
have some crappy
reconciliation loop.
what do you call it? GitHub workflow where I basically inspect the plan to make sure it's not deleting anything. But I thought to myself, come on, there's got to be a better way because right now we have a separate plan and apply stage. Why? Because we want people to do a plan before they and know what they're doing before they delete things. Unfortunately, no one really reads the plan, in all honesty. So there's that problem. So hence I have some crappy code to check for a deletion or a recreate. And I just think to myself, is this the way people do it? Is there a better way? I mean, that sort of life cycle type thing kind of sucks. That's my current
Yeah,
problem.
and that's also why a lot of people, when we talk about cross-plane, there's people very pessimistic around it because they put so much official or orchestration around this, plan and apply. They have a big ceremony around the process, and so something going behind the scene and constantly reconciling kind of feels wrong to them, right? And I think it really depends on the maturity. If you're Google and you're deploying 1,000 times a day, your services are reconciling,
Yeah.
and this is how you build your
I
architecture.
guess if you, I guess there's an adage with when it comes to. I mean, this is probably one of the first things I learned when I got into infrastructure is like don't manage your database in infrastructure as code. Because then you won't
Yeah.
have these problems. Like separate the data.
So that was definitely true for the longest time because stateful
Yeah,
Kubernetes clusters completely change your
maintaining a
operations.
database in I think there was a Kubernetes controller or something where you could spin up a database, and everyone said no, this is a terrible idea, and
No,
I
no, no.
quickly caught
I
on to
mean,
why.
if I talk about 2016, then stateful sets are like
Oh,
just introduced.
yeah,
And so at the time, the problem with Helm is that everyone can just pull a chart and go like, oh, Helm installed
Humsaw,
MySQL. There I go. I have MySQL now. Yes, but
and I've set up a huge cluster.
yeah, where is the data stored? Oh, so it's provisioning an EBS volume. How is the ownership of that EBS volume tracked? Like, what if you do an upgrade? How do you manage? And then people they build. This is like pets versus cattle, where you're building. Yes, you're creating a cattle of nodes, but you're building pet Kubernetes clusters. So what is the point of pet Kubernetes clusters? Then you need to start using Arcane or whatever it's called to create backups of your clusters and your control plane. I never liked that idea. I always made my cluster completely stateless so that I can
Yeah,
rebuild it.
a thermal. I don't know if I'm
Yeah,
pronouncing
so
it.
all of the state lives outside, right? That's how you want to build your microservices, if you can, depending on, what is the SLAs and what is your architecture that you have to support. But if you can, and you can perfectly scale horizontally, and you keep all of your data on a different tier outside of your cluster, then that makes life so much easier, because you can just blow away a cluster and rebuild it. You can
Yeah.
just put them side by side, and they can share the state outside of the cluster. And then once you start building stateful clusters, your SLOs are completely different. Your operations around those clusters are completely different.
Yeah,
And
but don't you think that like just going back to CDK, like I mean, a lot of tooling does bring state into it, doesn't it? A little bit.
sorry about CDK and
Like, sorry, I'm just trying to bring it back to CDK. Like, doesn't CDK? I think we talked about it yesterday. Like, doesn't CDK have like a strong concept of context or something like that? And that in itself is a state, isn't it? I mean,
so on one side, in these traditional infrastructure as code frameworks, you have the concept of a state. Like CloudFormation keeps track of the resources it created, and Terraform has a state file that keeps track of the resources it created, so that
yeah,
it knows, it ties back those logical ideas in the state file to the actual physical ideas. And if you remove a logic idea in your configuration, it will make sure that that resource is deleted. And if you modify the configuration in
yeah,
your
yeah,
logic,
yeah,
it will make sure that the actual physical ID resource is updated,
yeah.
right?
So
So it uses that state file.
yeah. So basically, I'm just hot, wiring these in my brain. I mean, I'm cross-wiring these in my brain. Like, if we have infrastructure and we want to have a goal of keeping separate state, I guess maybe it should be scoped to application state or something. But it's not. I mean, if you're religious about separate state, it's not that clear
You
to
wouldn't you
me
wouldn't
how
run
you'd separate it
Terraform
cleanly.
you wouldn't run a Terraform controller in your Kubernetes, because that means you're adding state to it. Or the Terraform
Mm.
controller must have access to an external state bucket within
Yeah,
that Kubernetes cluster.
it's got to be a very clear division,
Yeah,
right?
so that's a problem with crossplane, right? Because where does crossplane store that state tracking? It stores it inside the Kubernetes cluster control plane. So now you've created a stateful control plane. You've
Oh
created a
God.
stateful cluster. So that's where like, you're using crossplane to bootstrap Kubernetes, and that becomes a stateful cluster. So you need like one Uber cluster that controls all the other clusters, and that becomes your stateful cluster that you need to do very careful upgrades around. Operations are different, and of course, it makes sense for a company like Upbound, which sponsors crossplane, to say, hey, we are your Uber cluster. We manage that for you. We
Mm.
provide you a stateful cluster. We guarantee that your control plane is backed up and can be restored, and we're gonna take care of that. And that's the this managed service offering that they provide, and that's why they create something like crossplane, right? And I think Google Cloud went the same way. They have like Service Connect or Config Connect. They have a service in GCP that's very strongly based on of crossplane. That basically you define. And to be honest, Kubernetes is already taking care of a lot of your cloud resources, right? Because when you say I have a service and I need to make it externally exposed, it goes and creates a load balancer, right? So you already have a cloud controller inside Kubernetes creating AWS resources. You have a
Mm.
controller that creates nodes to add capacity to the cluster. You have a controller that creates routing rules, if you are depending on what type of networking that you set up, so that your routing tables can route the traffic between your pods across the nodes. So Kubernetes control plane already modifies your cloud and creates resources in the cloud. So it makes sense to extend that and also create databases and buckets and
Yeah,
other
yeah.
stuff.
This is where things get a little crazy to me.
Yeah, I mean, I I see the point. I think if you're going all in and you're a big Kubernetes shop, it makes sense. The only biggest issue I have with Kubernetes is that you have these declarative YAML that becomes super hard to manage. And
Yep.
then solutions like Config Hub make sense, because now you can define your load balancers, your buckets, your databases, everything in Config Hub,
Yeah.
and let the reconciliation loop constantly take care of it.
So okay, maybe let's turn the conversation back to AI. Like, if you were to if you were to like start on a greenfield project and use Claude to set up, I don't know, we kind of do need to scope this to some sort of example. Let's say that we need to run, I don't know, WordPress at scale, WordPress.com. So PHP, MySQL, blah, blah, blah. The
Be careful not to call
would
it
you do that in Kubernetes and just let Claude spin up some I don't know, CDK, what did we call it? CDK Kubernetes. Like what would give the best iteration, what would give the best AI friendliness slash iteration loop is what I'm thinking.
Oh, so this, are you thinking about what type of system would be able to leverage AI in the best way?
Yeah,
Would be intuitive to the AI, right?
exactly. So that kind of assumes the AI is sort of maybe kind of familiar to the workflow. I mean, you don't want to spend too much time teaching it something new, I suppose, is what
Yeah.
I'm trying to allude
So
to.
so that's where everyone jumped on creating MCP servers or finding ways to provide the LLM, the generic LLM that has been trained of lots of data, to basically give it the right context for the work that it needs to do. So if you take a generic
But
LLM model,
MCP is more for doing tool calls than giving context. Some people seem to mix that up a bit.
I think it's the difference is tool calls allow you to pull in context on demand. The LLM sees a tool that says you can call me to get information about the weather in London. You can call me
I
to
suppose,
so it's
yeah.
tool calls give the LLMs the arms and legs to reach out into the world to find information that it doesn't have. So
Yeah.
it can do it on its own. If you don't use tool calls, you as an operator of the LLM have to kind of figure out everything that LLM might need to solve the problem that you're trying to do, right?
Yeah.
So
But
before MCP,
on the subject of tools, Kubernetes tools, kubectl is pretty awesome, isn't it?
so that's where things have evolved, right? If you use Cloud Code Skills and you give it a high level overview of what kubectl can be used for, and then it goes and finds out more information about like the user has a problem with auto scaling, and I need to figure out if there's enough capacity in the cluster, and then it goes off and finds the kubectl commands that tells it how much like the top node stop, for example, to see how much CPU is being
Yeah.
used across the cluster. So skills are this like gradual discovery of information without overloading the context with every possible tool that the kubectl exposes, right? Because ultimately kubectl can be used in such a way that you can overload with like hundreds of tools, but you need to slice it and dice it down into like, if you're working on this particular problem, then you might want to look at these set of tools. And if you want to work on that type of problem, you want to look at this set of tools. So then Cloud knows like, hey, I'm looking at this type of problem. Oh, can we go look at those set of tools, and then loads them in and figures out that it needs to like, that's what the skills changed compared to tools, right? So if we go, sorry.
But which infrastructure as code technology has the best tooling in that regard? Kubernetes does come into my mind. Or do you think CDK is? I mean, are you managing infrastructure with AI and CDK? Is my next question.
Actually, funny. I can give you an example. Because when I built Terra constructs, I copied the AWS CDK interfaces. So my company, they adopted GitHub Copilot into PR review process. And my colleague created a pull request with Terra constructs that basically creates a load balancer, sets up listeners and things like that. But the code is TypeScript and it looks like AWS CDK. So Copilot started to comment on it and say like, hey, your load balancer listener here is not using TLS or whatever. So even though it hasn't been trained on Terra constructs, and
And it had no like what do you call this, type hinting, or
no,
had
nothing.
no.
I think, big part of the corpus. I don't think we can imagine how much of these weights actually encapsulate. It's like billions of internet data. You can ask it something silly like you ask about cats in Dendermonde, Belgium, and it will tell you about a tradition back in the Middle Ages where they throw cats off the walls. I was like, who would know that, right? And it's not made up, like it's true.
What? Why
They
did they
used to
throw
kill
cats onto walls?
after the winter. They kept cats to prevent the mice to eat the grains or something, or to bite. The rats or the mice were destroying all of the storage, like the linen and so on. So they have cats to hunt. But then when the summer comes around, they have too many cats, so they threw them off the towers. Belgian tradition.
So dark. There's
So
always
this is
like
one thing,
with
which is
Belgium,
like,
there's always like some dark stories. Like,
yeah, so if
thanks
it
for
knows
that.
this horrible detail that we Belgians have been trying to hide, of course it's going to know how to write AWS CDK.
Interesting. So you're basically saying that it doesn't matter what you use, AI is going to be flexible enough to get you there.
And what I'm saying is, for me, and the reason why I spend all this time on what I'm doing, for me, AI is pure intuition, right? All of this hallucination, which sometimes we don't like, but sometimes it is pure, like, out of the box thinking, and we embrace it. All of this hallucination is intuition. It's built into the model to like feel like that's the way I need to go. So whatever framework you work with should be an intuitive framework. So I feel
Don't know
AWS
what.
CDK is beautiful because it's all about intent-oriented methods. It's not like this massive declarative, get every single attribute correct or it's not going to work. It's intuitive. It's like, I want to deploy my service. I want to spread it one per node, and I want the spot disruption budget,
That's a good
and you do
argument.
it intuitively.
Intuition.
Yeah, so that's where I feel like it's been trained heavily on TypeScript and JavaScript because that's like still in the top one languages of Stack Overflow every year. So it
Yeah.
has a massive amount of JavaScript samples and TypeScript samples. It has, I don't know, probably more JavaScript, and it has the ideas and hallucinates constantly. It's actually like LLMs is all hallucination. Like every single token it outputs is just hallucination and intuition, right? So the fact that it's correct, these hallucinations is mind-boggling, right? But the fact that it can generate AWS CDK correctly and in TypeScript, to me, is proof that I would rather focus on a high-level language like that
Yeah, but don't
than
you think it's
on.
strange? Don't I mean, surely going back to what I was asking earlier, like, so you don't give it type hinting, like, surely if you let Claude, I mean, VS Code must somehow do this, but like, if you open up a project with type checking, then and you let Claude make some changes. Surely
Yeah,
it can recognize that it's done a bad change when the
yeah, yeah.
LSP starts
And this
failing,
is the
right?
agent's shell, right? This is how the shell surfaces the information to the LLM. It captures a whole bunch of information. It also gives it guidelines. Like, I made a change. Like, if you look at Cloud, it will say, I made a change to this file. Let me make sure. I don't know. It says low bandwidth. Maybe my connection is bad.
Yeah, yeah. You just dropped out a bit.
Sometimes Cloud says, yeah. So Cloud will say, I made a change to this file. Let me run the tests, or let me run this. This is like agent shell instructions, right? This is like part of Cloud Code's magic sauce. It just says, like, you do this, then you do that. You run this tool. You connect to the IDE and look for the problem. If you go to Visual Studio Code,
Yeah, yeah.
you
It's
can see
part of
problems, and it
the.
says for each file exactly. Yeah, language servers, integrations, and so on. So this is agent cell. This is IDE context. This is what makes a coding agent good at what it does by surfacing the information in small bits right when it's needed.
Yeah,
And
it's such an incredible technology, isn't it? It's so incredible.
so what I wanted to give you an example of where I think it's obvious that cloud will not be good at doing things with Terraform compared to AWS CDK.
Okay, juicy.
I had the requirement, a theory to set up swap files for nodes because we wanted to allow bursting. You can overshare resources on a node, and we wanted sometimes resources to be oversubscribed and some services to basically burst out and take more memory than the node has. So we wanted to alleviate some of the pressure by creating a swap file on disk. So I asked Cloud to help me prepare the launch templates for the autoscaling group. And this was pure Terraform, no AWS CDK. And to do the swap file configuration, you have to define the swappiness on the task definition. But on Terraform, the task definition is a massive JSON blob, right? Mm-hmm. It's just a massive JSON definition. And Cloud can do like the first level of attributes of this JSON definition. It can do it decently. But when I mentioned about swappiness, it also just put the attribute swappiness straight on like the top level as an attribute, as a field on a JSON document. And it didn't work. Or it looked like it worked. It didn't give me any errors, right? But when I looked into it, it actually didn't work. And I had to look really deep into the AWS docs to figure out that swappiness was not a top level field, but was nested within something called kernel attributes or something like that. So on the ECS task definition, you had to create a field called kernel attributes. I'm not sure. I'm just making that up, but it was something like that.
Yeah. Okay,
and then there was a field under there called swappiness that you had to set to like a certain value to actually take effect. Now, both the AWS API did not throw an error because it just ignored any unknown fields. And Cloud did not know what was wrong because it's just a JSON blob. But if I look at AWS CDK, they actually exploded this into a construct. They created a task definition construct, and every possible field is properly structured in a TypeScript interface. So if you put swappiness at the top level, you get a TypeScript error. That doesn't compile.
Yeah, but you're assuming that someone's done the work in the CDK land.
And that's the craziness about the AWS CDK, is that somebody has been doing the work for 10 years, and it's like 100 contributors, and it's spread across the service.
But that could work against you. They might not have been well maintained, and you can't set.
Well, that's why a framework like that needs to be backed by the cloud provider. This only works on AWS CDK because AWS invests resources into building this library. And that's why AWS CDK is much more powerful than Terraform, because it's backed by AWS and fine-tuned for its cloud.
And that's what they use internally, is what we also...
Yeah, exactly. Because when I look at the pull requests, they're like, I'm at the service team of AWS and we need this, this particular EC2 or task definition field needs to be made available.
On the topic of CDK, let me just share my thing again. I had a question for you on operational flexibility. Or operational features. Okay, so here's an example. I'm maintaining, let's just call it an Airflow, an AWS MWAA Airflow instance at work, and it's getting overloaded. I need to scale it up quickly. So in Terraform, if I was managing Airflow in Terraform, I would set the CPU type from, I don't know, T1 to T5 or something, M1 to M5 or something, right? And then I do a plan, and then I do apply, and I don't know, half an hour later, the instance of Airflow would have been updated. In AWS CDK land, again, I don't think it's any faster, right? You would still have to go into your CDK code, change something, and then do a CDK deploy. And it's probably the same amount of time as the Terraform plan and apply, right? What I'm trying to say here is there what's the quickest way to make a quick change of these technologies? Besides, don't say ClickOps. I mean, yeah, I think ClickOps is probably the fastest. You know what I mean? The speed to make a change. I don't think we captured it very well.
Yeah. I mean, it's a trade-off, right? That it's all or nothing in these frameworks, right? You either go all in and you make single source of truth, Terraform, and there's no way of making a change outside of Terraform. Or you completely ignore that attribute in Terraform, and then people can change it, and Terraform will not complain or try to revert it. You can say lifecycle ignore this attribute, so you will not try to reset it. That's where other frameworks recently try to improve, because they say by nature the cloud is bidirectional, it's not one way. Forcing your infrastructure as code to be single direction, single sort of truth, in practice doesn't work. It slows teams down, and that's where config hub, that all of what I just said is basically from a blog series from Brian Grant, right? The guy who then announced config hub. So their idea is that you must be able to go into your config store and change a value and have it applied quickly without going through a massive and slow process. But that's a trade-off, right? I mean, their point is that if you do it through our system, I guess there's more tracing and more control over it than if somebody goes in ClickOps. At least as the config field is stored inside the data, and you can have an audit trace there. I don't know.
Well,
And you can
get.
modify it.
I do feel you can have your CloudTrail events siphoned off to just note what infrastructure changes there are.
Yeah. So System Initiative, they also have this idea of we are a digital twin and we synchronize whatever you do in AWS back to our.
I need to give a system initiative a trial before I meet up with
They have
Adam
great
again.
ideas. I mean, the people behind it have a lot of experience with Chef and Puppet, and they're some of the original creators of some of the ideas of how Chef originally worked, and they have carried over after working with Terraform for a long time, and they just built a new idea. And the way I understood from his podcast that I listen was that System Initiative is a programmable graph. So you create nodes, and every node in the graph has hooks like create, read, update, delete. And those nodes, those hooks are all programmable. So you can decide this node, if this gets created, this node, if it gets created, this is how the function runs. And this node, if it needs to be updated, this is what function it runs. And you can therefore build your own nodes. It's kind of like Terraform provider resources, right? But all split out into individual node, because a Terraform provider resource has create, read, update, delete hooks, right? And the Terraform provider just looks at the graph, determines that node needs to be updated, and then calls the update hook for that resource and gives it the the actual values and the new values, and then that resource, as part of the provider, will apply those changes by making the correct AWS API calls, right? So they kind of take this Terraform provider, but they split it out into individual programmable nodes, and then they re-implemented each of those nodes. What I don't like, as far as I understand, is that under the hood, every single function of those nodes is like using AWS CLI commands. So it doesn't like it and I don't know. Because honestly, I think they spent 4 years rebuilding Terraform provider AWS by defining every resource type as a node and giving it create, read, update scripts. You've only done the very basic foundation, because what really makes infrastructure as code powerful is like what I just told you. 10 years of AWS CDK and hundreds of contributors splitting out every possible field and building integration patterns, right? Imagine you spend 4 years re-implementing Terraform providers and offering it as a solution, and you haven't even gotten to the level of like, now I have a Lambda and a gateway and I need to integrate them, and that means I need to call all of these resources and I need to call all of these hooks in sequence. But
in an ideal world, the AWS CLI should be exposing these things, should be exposing even these high-level abstractions in some ways. The AWS CLI, I'm just playing devil's advocate here. The AWS CLI should be actually the interface should be enough, is what I'm trying to say.
Yeah, so I haven't played enough with System Initiative, but I can imagine that based on what he says, if they started from scratch, it would take an immense amount of work to reach anything like AWS CDK level of UX or DevX, developer experience. And sure, you can show a demo, which he says we have a demo where you give us your AWS account and we point system initiative at it, and it will very quickly create your AWS account resources as a digital twin in our graph, our programmable graph. And you can immediately start modifying them through our interface with our digital twin technology. But that doesn't talk about I am a developer and I need to deploy Next.js. And I don't care how to set up API gateway and every single Lambda so that Next.js has a server side and can execute, right? Because that is what a developer wants to do. This is the actual functionality. Like I started I started my career, understanding how the control plane works, how reconciliation loops works. But if you work for an organization, nobody cares, right? We need to deploy the feature. And what is the best architecture for us to deploy it? I don't care how Kubernetes, etcd needs to be set up and backup procedures and all that.
Yeah, you just want to write code
yeah, that is the business value. Unless you're a hosted Kubernetes cluster provider, as a DevOps engineer, you're coming in and only knowing how to set up clusters, you don't bring any value unless you can do these high-level integration patterns. And after, it was very interesting for me, but after doing it for 5 or 6 years, I wanted to actually be valuable. Actually focus on these harder, these
and I
actual
guess these high-level integration patterns, as you are only really possible with CDK, right?
Yeah, so CDK is great, but there are obviously, I think, other approaches like Pulumi. I was very surprised because CDK has this, as I just explained, it has like these amazing deep level integrations within the AWS services. So if you take a TypeScript object that represents an API gateway, it gives you a method to like bind it to a Lambda, and it knows exactly what to do under the hood. Pulumi is kind of like starting from scratch and then build little like helper methods on top. For example, the bucket object that you get within Pulumi has the idea of like on event hook, and you can put the function handler in that on event. It's on the bucket object. You should search for bucket.onEvent. And apparently that's not in their like L1s, but also in their like higher level on event. Yeah. I see it's in Pulumi crosswalks. So AWS CDK is like the L2, right? And crosswalks is like their version of L2. It's like you take the low-level bucket API object, and then you add ideas on top of like .onEvent. And that's a really neat little thing. But again, it required somebody at Pulumi to implement the idea of a bucket, a CloudWatch rule, an SNS topic, have this idea of invoking a function. And thus they created a repeatable pattern that on event you pass in the function handler, and it will automatically create the bucket, create the Lambda, create the bucket notification that calls the Lambda, set up the Lambda permissions, everything for you, right? And then the on event is like this pattern that they expose. It's an interface because it's a programming language. So you can re-implement it. If you have something of your own that you want to implement on event, then you can implement exactly what are the grant permissions that need to be added to the policy. So you can implement your own on event. So that's the benefit of using a programming language. You can create an interface, you can define a contract. You can't do that with Terraform modules. Can you try to think about doing that with Terraform modules?
Well, and I'm going back to your IAM example. To achieve these privileges without some sort of dynamism is going to be hard.
Yeah, it's exactly because of you have this like synthesis time, lazy evaluation, late binding, setting properties after the program has executed.
But I can't help but think this cuts both ways. I mean, there's an argument
to IAM policy that you want to attach.
There's an argument to be made. Is like as soon as someone starts writing a whole bunch of code with like on event logic, it's going to get probably quite difficult to follow, right? The beauty of opening up a lot of Terraform projects is that you kind of know what's happening, and it's constrained by the language, right? If people, like, just
For
like
you,
any code in the world, if people can do things, they will, and it will just get complex
yes, but
without any abandon,
I
right?
just got the question today from someone. He says, like, do you think that it makes sense to target an intermediate DSL? And when you're saying what you're saying just now is like with the Terra constructs, if you do this complicated coupling of creating a Lambda and an API gateway, ultimately when you run synth, you get a flat config file, which is the DSL that is Terraform, and you can run your whatever linters and problem
Yeah,
detectors
but
and
it's probably going to be fiendishly complex. But yeah, okay.
yeah, because the cloud is complex, dude. This is what the whole
Yeah, I mean,
the trade-off is you're getting capabilities, elasticity, and uptime for services to move fast in terms of a business value. And does it end up being complex? What's the alternative? You're going to spin up an EC2 instance and build your own, and then you build
yeah. I
all the
mean,
liability on it. It is going to be
there's
complex.
different ways of looking at it. Like, the more I need to give System Initiative a bit of a whirl, to be honest.
Yeah,
But I'm
me too.
starting. But like, I'm I'm working backwards from AI, and I feel with AI, it's about. I mean, it's also about the same thing for humans, really. It's about iteration speed
Yeah,
and a tool chain. Like, I'm just thinking aloud that, like, maybe calling AWS CLI from Claude, something what System Initiative does behind the scenes, is perhaps not a terrible way of bootstrapping an account, right? To what it needs to do for a you know a typical organization.
and let's take a step back. What you just said about iteration and achieving results quickly. It's kind of like how I was understanding what you're saying. I think this is also related to people like originally people were like, oh, Kubernetes is going to give me this full cloud independence. I'm going to be able to do multi-cloud, as a resilience strategy and everything, right? Very quickly that breaks down because the advantage of being in a cloud is to maximize its capabilities. Like if you're an AI team and you need to set up like this complex data ETL pipeline, but you need to be completely cloud independent and you need to do everything yourself versus, oh, I'm going to use some step functions or durable lambdas now, and I'm going to leverage all of the serverless capabilities, and I've got something working, because you have like DBOS, you just define your programming, and then under the hood, whenever a function is called, it can be suspended and it can be persisted, and I don't need to worry about exactly how all of that works. I can just focus pure on my business flow, and it's a neat, clear data pipeline. And under the hood, it's automatically creating lambdas, and they are being suspended when they're waiting for events, and they're resumable, and it's taking care of making sure that the event is propagated and no notifications are being missed, and all of this like fault tolerance and repeat, and that letter queue setup, and all of this complexity gets handled by a cloud layer, and that gives you the ability to move forward and to actually deliver a feature. That's in an organization that's between being the market layer or being leader of being out of the market and closing down. I worked in
Okay,
many
so
organizations.
okay, just to replay my understanding of what you just said is that, like, if you don't uh, if you don't get get
Realize a
get
competitive
down in the
advantage.
weeds, then you're not really innovating. Type is what I heard.
It's more about if you what business are you delivering? What is your core business, right? Your core business is not creating a perfect ECS cluster and taking care exactly of like setting up a pipeline that does exactly one delivery of all the messages and does all of this core like engineering. Most organizations just need to deliver business value, or they die.
They're out of
Like they
business,
don't.
yeah. And then I think you made the argument that like you can't do this in the CLI. You need to get down into the details. I mean, sorry if I
No,
misunderstood
my
you.
link back to what you were saying earlier about um, my link back was basically maximizing high-level services of clouds without worrying about it not being reproducible or yeah, I don't know. I had a point.
Okay, sorry, my kids need to be taken to school,
Waiting.
so we ran out of
It
time
doesn't sound
again.
like I have a point just now. I need to rewatch this to remember what my point was.
Okay,
I'll put it in the comments.
we'll get to the point. Thanks for watching if you're watching
All
this.
right.
Bye.